this topic, we have discussed situations that have occurred on horizontal surfaces. Now we're going to talk about what happens if instead of a horizontal surface, we have an inclined plane. So the surface is no longer horizontal, but has a horizontal and a vertical component. So I have drawn in white here a inclined plane, and I've labeled here the angle of inclination. So whenever you're given an angle for an inclined plane problem, you'll be given the angle of inclination, or this angle down here. Now, we're going to have to do a trick to make these problems a little bit easier for ourselves. Because, let's look at our box here. We have a force normal that is perpendicular to the surface, a force due to gravity that's always going to act in the negative y, and a force due to friction that's going to oppose the motion because, well, we'll talk about how there's a force forward in a second. Now, if we used our standard coordinate system where we had positive y, negative x, positive x, we'd have to break an awful lot of forces into components, everything except the force due to gravity, because you could also have an additional force applied down the incline, in which case you would have to then break that into components. So instead of having to break a lot of forces into components, we're going to rotate our coordinate system so positive y is normal to the surface, negative y is then opposite to that, and for this case I'm going to put negative x up the incline and positive x down the incline. Sometimes I flip and flop that back and forth. Alright, so that means that the force normal is now once again along the positive y direction. The force due to friction is along the x-axis again. So the only force we have to then break into components is the force due to gravity. So let me talk about how we're going to do that. So we have the angle of inclination, I've labeled theta down here, and I made a right triangle with the force due to gravity. So this is the right angle I've labeled here. So I've labeled alpha here. So I've labeled the two interior angles. So because this is a right triangle, alpha plus theta must equal 90 degrees. Now I'm going to draw the free body diagram. I'm going to rotate the free body diagram. So we have force normal in the positive y. We have force of friction in the negative x direction. And force of gravity is going to be over here in the fourth quadrant. So this here would be the positive x-axis. And this is going to be force of gravity in the y. This is going to be force of gravity in the x. Alright, so if we look back in our diagram, the angle between this is the positive x-axis and the force of gravity I've labeled as alpha. The positive x is here, the force of gravity is here, so that makes the angle between them alpha. And this here is a 90-degree angle. So 90 degrees equals alpha plus question mark. And question mark, in order to match this back here, has to be theta. Now we do have to be careful here. Theta is opposite to the x and adjacent to the y. So for x we're going to use sine since it's opposite, and for y we're going to use cosine because it's adjacent. So force due to gravity in the x is going to equal the force due to gravity times the sine of theta. And force due to gravity in the y is going to equal the force due to gravity times the cosine of theta. Remembering that the force due to gravity is equal to m times g. And this is how we're always going to set it up for inclined plane problems. And these are on your equation sheet, so you don't have to remember that they're flipped for inclined plane problems. So you have to use sine for the x and cosine for the y. But you do have to know where to apply that. Alright, so this concept explains why if you put an object that has enough mass on an incline that is slippery enough, it'll actually start sliding down on its own. And it's not because there's some mysterious force applied that you can't see acting on it, it's because of the force of gravity in the x. So at the top of an incline and you're trying to go down, the force of gravity actually adds a positive force and helps you go down the incline. But when you're pushing something up an incline, it actually works against you. So you have to apply more force to overcome that force due to gravity. What's nice is because you're an angle you're not trying to lift against the whole force due to gravity. So if you're actually just lifting the object, if you're using the incline, it's split in the components, and you're only working against the x component and not against the y component as you're trying to apply a force in the x to push it up the ramp.